Hi, I'm Jamilla Teixeira. I'm assistant professor from the Civil and Environmental Engineer Department, and I work with the development of materials for civil infrastructure. My science journey started a while ago, but I can say that in 2004, when I came to you and I was an exchange student, it's that when my passion actually became bigger and bigger. I met my former advisor, Dr. Jan Rakin, and he taught me about materials, aggregates, binders, and alternative paved materials, and invited me to do graduate school. So I did my master's and PhD, and he taught me that we should always link pavement performance with individual material behavior, and never lose your enthusiasm, because research is not a one-way street. You may face difficulties, but you should keep focus and keep your enthusiasm, and then you can reach bigger goals. So with that in mind, I started developing my career and centering research questions such as, can we use alternative and more sustainable materials to build roadways? We have just one planet for everyone. And did you know that we have about 35 million tons of waste plastics generated in US annually, and only 8% of those plastics actually are recycled? We have about 2 trillion tons of plastic particles underneath the ocean. So we need to find ways to repurpose this material. And one of the ways is maybe we can incorporate this to produce asphalt mixtures and build pavements. So with those questions in mind, I developed some 3 hypotheses, and one of them is plastic can create a stronger bond with rocks and asphalt, and also different waste plastics will have different effects on the final plastic asphalt strength, and the mixing temperature will impact the interactions of waste plastics with other asphalt constituents. To answer that hypothesis, then I start collecting data. I visit recycle facilities, I collected few samples, and we start characterizing the samples with my students, and we tested those, and we need more data. We try different mixing procedures, how to add the plastics, different types of plastics with aggregates and binders. We test to see cracking resistance, rutting resistance, moisture damage resistance, and we start getting data, and we saw the effects of mixing temperature on the material performance. We saw that different types of waste plastics will lead to concretes that resist differently the applied load. So we saw, based on those results, that plastic can be added at very high temperature. But what happens if we add that plastic in an actual asphalt plant? Will plastic melt? Is this going to be feasible? So we could go to a fielding project and actually work in an asphalt plant, and we could see that was feasible to mix in an actual asphalt plant and build the pavement structures. Then we collect more data, analyze, interpret, and check our hypotheses, but we had to go back to a few questions. How about in long term? This pavement is going to resist with plastics, and what I observe in the lab can be mimicked to the plant. So we collect more data. I partnered with other colleagues to monitor the pavement, and we collect materials, and we start presenting this data in conference, talk with my research groups, and just advance this research. So why this matters? This matters because we can help diverse solid waste from the environment while creating an opportunity to build stronger and more sustainable road systems for everyone. Thank you, and we can talk more about this, and just reach out if you are interested.